Conveyor belt tracking instruction.
This course will be divided in 4 main parts. 1. Introduction of conveyor belt tracking. 2. Encoder wiring. 3. Instruction usage. And 4. Methods of programming. The course duration will be around 10 minutes and the main goal is being aware of conveyor belt tracking function.
Introduction of conveyor belt tracking application. This video is an overview of the application. The robot is tracking and gluing the product. Then, it takes the product out. Let's watch it. Let's have a close shot at it. Now let's see the encoder wiring of the conveyor belt tracking instruction. On the picture on the right, the red rectangle marks the high-speed interface, which is for the conveyor tracking encoder connection. The table below is for the terminal rank connection. Pin 1 and pin 8 are for the 5-volt power supply positive connection. Pin 16 and pin 9 are for the ground connection. Pin 2 and 3 are for encoder phase A positive. Pin 14 and 15 for the phase A negative. Pin 4 and 5 are for the encoder phase B positive connection. Pin 12 and 13 are for the encoder phase B negative connection. Pin 6 and 7 are for encoder phase Z positive connection. Pin 10 and 11 are for the encoder of phase Z negative connection. This HSI for the ABZ encoder connection supports both differential signal type and single-ended signal type. The wiring method are as below. Regarding to the encoder with the instruction manual, wire it to the HIS according to its datasheet. For those encoder without instruction manual, identify the signal wires with oscilloscope before proceed wiring. For encoder differential signal wiring, the related signals of encoder shall be wiring as the picture and table below. Pin 1 to 8 connects to the phase A, B and Z positive and negative. Pin 4 and pin 5 connects to the 5-volt power supply positive and ground separately. The second type, NPN type, open collector output encoder and the voltage output encoder. NPN type, open collector output encoder. The schematic diagram is as the left picture, the voltage output encoder. The wiring method is the same for the two types of encoders. The actual wiring is as below. Pin 1, 2 and 3 connect to the encoder phase A, B and Z positive. Pin 4 and 5 are for power supply connection. The third type, PNP type open collector output encoder. The PNP type open collector output encoder, the schematic diagram is as below. Pin 1, 2, 3 are for phase A, B, and Z negative connection. Pin 4 and 5 are for 5-volt power supply connection. Instruction usage. Read the relative reading and status of the encoder. Note that Conveyor instruction requires the controller version 1.5.12.25 or above to function. First of all, connect the encoder with the controller according to the procedure mentioned above. Second, use Modbus port to connect the encoder. Then, we could read the encoder reading and status according to the version 1.5 controller Modbus address table. Select and click Conveyor Belt Tracking instruction. We could set up the pulse equivalent and conveyor belt direction in the pop-up window. Regarding the pulse equivalent, we need to read the encoder pulse start value and then the end value. Then calculate it with the distance conveyor advanced. The pulse equivalent equals to the pulse difference divided to the distance. There is currently two methods. The first one is to read the pulse difference and the pulse distance. Pulse from Modbus and distance with the caliper measured. The second is to calculate the encoder traveling distance per rotation. Then, read the pulse difference per the rotation via Modbus. Use those two for calculation. Regarding the conveyor belt direction, we could either use the manual input or position setting function. For manual input function, the X, Y, Z represents for the direction difference comparing with the origin of the user coordinate system. For example, 1, 0, 0 stands for the direction is along with the X-axis positive direction of the user coordinate system. While for the position setting method, we need to click Start or End position and set up the robot position. The instruction will calculate the conveyor direction according to those two positions. The conveyor direction is from the start position to the end position. Only position will be calculated regardless of the pose. This method is recommended. The conveyor direction X, Y, Z will be difference value of end position deduct the start position X, Y, Z. Method of programming. The sample program is at the right picture. The robot will start from the joint movement, then, according to the pulse equivalent and the conveyor direction, start the linear motion and relative linear motion with the compensation for the conveyor motion. To achieve the tracking result, then wait for 1 second to repeat the motion. This is the program for the first demo video. First of all, set the outfeed and infeed slide cylinder as the initial status. Then, wait for the front load cylinder extend to fit in product, then start capturing while the product reaches the camera triggering position. Retract the front push cylinder. Wait for 2 seconds for the camera to process and start capturing. Wait for another half second for the camera feedback and read the X offset from that. Then compensate the X offset to the position offset. The robot will move the linear to the standby position in advance, which is the starting position of the circular motion. Wait for start tracking signal in, then record the conveyor tracking instruction. Move with 2 semicircular paths, then the robot will move linear to the position above the center of the product. Open the vacuum and bring down it to pick up the product. At last, the robot will move to the fixed position to unload the product and retract the cylinder for the next cycle. That is all for the conveyor belt tracking. Thank you for watching.